Hello, folks. All right. Well, what I want to do today is to give you a little bit of an overview of the language that we're going to be translating from this term. So, in both the labs and the project, we're going to be reading code that's written in this new language and translating it to something else. So, the language itself is called Wonderful, a brand new language. Sorry for the name. And basically, the language provides a way to describe how an AI moves around a two-dimensional map. So you can create these AI characters and tell them to, move north until something happens and then turn left. And so this kind of an idea. Or I guess turn east or west or whatever it might be. So the language is basically just about creating and moving AIs around a map. So what I'm going to do is give you kind of a quick look at a sample program, and then I want to back up and talk a little bit about the labs and the project in general, and then we'll spend a little bit more time talking about the specifics of the language. All right, so just taking a quick look at this sample program, and I'm just going to ditch the good old talking head there. So the sample program we've got here basically shows you what a comment looks like. So this is just an example to show you what a wonderful program might look like. You can set the size of the map. There's a start and a finish that indicate the beginning and the end of the program. You can go through and create new AI characters and then give them instructions as the program runs along. So some of the examples, you can create Bob, for instance, and you specify what row and column they start in and what direction they're facing when they're created. Again, this doesn't do much other than moving folks around for the program as it exists right now. You can give instructions in the form of a loop to say, keep moving, keep doing this until whatever. So in this one, it's saying, let's keep moving Bob around. We'll move Bob 2 units in whatever direction Bob is currently facing. We'll make Bob turn. We'll make Bob move 1 direction or 1 unit in whatever direction they're facing. Then we'll turn Bob again. We'll print current information about Bob. And we'll keep doing this until the row that Bob's in is bigger than the row that Fred's in. Just as an example. Again, don't worry too much about the syntax and the gory details. Just an example of the kinds of things we want to be able to do in the language. And again, it will support if statements where we can say if blah, 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 then do whatever this is. So again, just some basic programming features. At the moment, it doesn't support variables. It doesn't support subroutines. All of those things we'll be adding to the language as the semester goes along. So our general objectives are going to be in each lab, we'll get a little bit more detailed in what we can translate in terms of our source code language. So how fancy we can get when processing programs that are written in Wonderful. So what we're going to do in the labs is use 2 of the automated tools, Lex and Yak, that work off grammars describing the language and produce translators for us. In the project, on the other hand, we're going to be handwriting a C++ program to act as a compiler for Wonderful. So we're going to essentially, in the labs, we'll use the grammar-based tools, and in the project, we'll go through and do some custom development of a compiler for the language. So in the beginning, we aren't going to worry about compilation. In the beginning, all we're going to worry about is pretty much syntax checking. Just reading a Wonderful program and figuring out if it's actually valid or not. So for Lab 1, you're going to be using Lex and Yak just to go through, read a Wonderful program, and figure out if the basic structure of it is right, if the structure of the repeat loops are right, if the structure of the overall program is correct, if the structure of the if statements are valid, that kind of an idea. So it's really just going through and doing very basic structural syntax checking. Then in Lab 2, we'll start adding checking for things like, make sure that an AI has actually been created before we try and move it or print it or something like that. And we'll make sure that we start doing checking for, you can't declare the same you can't declare 2 AIs with the same name, that kind of idea. So In Lab 2, we're going to start getting a little deeper into the error checking. In Lab 3, we'll start adding new syntax features. In Lab 4, we'll get into adding subroutines and whatnot. So again, for those first 4 labs, we're basically just going to be expanding the language and expanding our ability to check the validity of wonderful programs. And then in Labs 5 and 6, you're going to take your brilliant syntax checker now and start getting it to produce code in a target language that's basically just going to be a subset of Bash, but we'll get to that later. So this is the plan for the labs. If there's enough interest, depending on how overwhelmed folks are, I can talk about adding a bonus lab towards the end, and so we'll get into that a little later, where we start introducing obstacles and things into the add syntax to the language so that we can describe obstacles on the map and deal with things like, well, what happens if the AI bumps into a wall when it's trying to move? So that's a possibility for a little later, but we'll talk about that later. And again, the project is going to be doing similar things. We won't be getting into the discussion of the project too much for about a month yet, because we want some basic knowledge of what we might be doing first. So that's the essential idea. Again, since we're going to be using Lex and Yak, which are based off grammar descriptions of the language, you're going to need to get familiar with those first. So again, in terms of if you're looking for information about the labs in the project, from the main page, hit the labs link. Again, just a general blurbs on what each of the labs are worth, what the final project's going to be worth, late penalties, all that kind of thing. This stuff does tend to be quite finicky. It's quite detailed work, and it can get kind of complex, so don't leave working on these things until the last minute. Right? If you run into problems working with Lex and Yak or developing your custom compiler code, you are often going to find that you need to step away from it for a night and come back tomorrow with some fresh ideas and a fresh take on it. So don't leave this till the last minute. The other thing is, for these labs, as you saw from our kind of run through just a second ago, they build very sequentially, right? You use everything from lab 1 in lab 2. You use everything in lab 2 in lab 3. So even though I'm going to drop your lowest lab mark, if you do something like skip a lab entirely, you're still going to have to do it for the next lab to get the next lab working. So if you skip lab 3, you're going to have to do lab 3 and lab 4 to get lab 4 working. So just a word of warning. We'll get into talking about feedback once I actually have something marked for you. If we're going to be using Git to do our distribution of the lab and project material and to get you to submit it, so hopefully most of you are well familiar with our Git processes by now, but if not, there's a collection of videos going through the process, and we can talk about it in the lab Zoom sessions as well. So the big things that you're going to need starting out, and this is essentially going to be what we do with the lecture material and the lab time for that first week, we're going to need to go through and make sure you're up to speed on how to formally describe languages, the use of regular expressions to describe tokens within a language, the use of context-free grammars to describe the structure of a language, and the use of augmented grammars to handle some of the semantic checking associated with a language. So all of that will be videos and discussion for the first week of lectures, and then getting into the gory details of Lex and Yak and how they read these grammars and how the grammars have to be expressed and how we essentially create C++ programs based on those, as the other half that we'll essentially dedicate the lab time to for that first week. Once you've got a decent handle on Lex and Yak, I don't think Lab 1 is going to be horribly ugly. It's just getting used to working with Lex and Yak and how to express your grammars. So again, in the material here, the labs overview is that page I was just on a second ago. The project overview we'll take a look at in just a sec. Or actually, I might do that in a separate video. But so going through, we've got our plan for the labs, and there's a description of the wonderful language so far. And again, we're going to expand on this as the semester goes along. So essentially, comments are the kind of single line comment style where everything after a percent or from a percent sign on to the end of the line is a comment. We'll use white space to delimit a lot of the different tokens. So this can be, spaces, tabs, new lines, and you can have any number of white space tokens as a delimiter. So you might have 12 spaces, a tab, and a couple of new lines, but whatever it might be. In terms of the grammar rules themselves, again, this is going to be essentially a description of what the rules of the language look like from a structural perspective. So names for AIs consist of an uppercase character and then one or more lowercase alphabetic characters. Numbers that we'll be using for rows and columns and distances and things are essentially just integers. They're one or more digits. There's a series of different operators that we'll use, semicolons, the less than or equal to, and equal. We'll be using the less than, greater than, greater than, less than symbol as not equals. And we'll be making use of brackets in some of the different structures that we've got here. So those will be the basic symbols that we're working with, at least in the beginning. And then the grammar rules for the language, essentially we tell you what different portions or components of the language are going to look like. So a program is going to start with a map size instruction, and that's going to be followed by the start keyword, and then a bunch of statements, and then a finish, right? Which pretty much matches what we saw back in the beginning. We've got a map size, we've got a start, and we've got a finish, and a bunch of statements in between. So as you'll see, keywords in the language are all denoted in lowercase here, and components are denoted in uppercase here. So a program is made up of this stuff, where number is a component, right? We've defined it earlier up here, one or more digits. Semi is the semicolon, right? We've defined it earlier. Statements, we've got a rule for below, right? Where statements is essentially a list of either a single statement or a single statement followed by more statements, right? So it's essentially one or more statements. A statement can be any one of three things: a select statement, a loop, or an action statement. And again, we've got rules for each of them, right? An action statement, there's 4 different kinds. You can use the keyword print, and then the name of an AI, and then a semicolon, or you can use move, the name of an AI, value, and then semicolon. So just the valid structures for different action statements. And again, this just goes through, tells you what the loops look like, tells you what comparisons look like. That should actually be in uppercase. I will correct that in just a second. Let's see, and again, going through, we've got all of the different rules for the language initially. And then at the bottom, we've got an expansion on what the meaning of the different pieces are. So it tells you what a move is actually supposed to do, or what a create is actually supposed to do. Tells you what the built-in functions are supposed to return. So what we're going to do for Lab 1 is essentially just develop a program that checks to make sure that a wonderful program has the right structure for those basic grammar rules. We won't worry about any of the semantic checking for Lab 1. We'll start getting into more of that in Lab 2. So you're going to need to familiarize yourself with the language and with the grammar rules and with Lex and with Yak, and that will essentially be where we take off with for our Lab 1. So I'll talk about Lab 1 in a separate video, and we'll talk about the project part in a separate video as well. All right, again, we'll have Zoom sessions for each of the labs, and in those we can handle any questions that you've got about the project in the lab and that kind of thing. All right, and we'll start the labs in week 2. So no labs the day of the 7th, but we will start them on whatever it is that 8th, 9th, 10th, the 11th. All right, I will leave it there for now.